When I was a kid, I wanted to be as cool as the people in the science fiction movies. This gave me two options. I could either become a Jedi or a physicist. Since the lightsaber technology was not doing very well, I decided to become a physicist. But this was definitely not enough, since the physicists in these movies are often doctors. So my only choice was to find a place for my PhD that was willing to defy science fiction. And then I found the Large Hadron Collider, the largest particle accelerator in the world, a machine with a vacuum that stirred on the interstellar void. It's colder than outer space. Its goal, to discover what the universe is made of. I had found a place where I wanted to work. The Large Hadron Collider, or LHC, it's a circular accelerator where we collide particles to see what's inside them. To guide the particles around the accelerators, we use 1,000 dipoles, superconducting magnets that have to be cooled down with cryogenics, dipoles, quadrupoles, and the list of devices with weird names that we use goes on and on. Right now, the LHC, it's been upgraded to an even more powerful machine. This means that we'll have more collisions than ever before. For this, these devices will be changed, and some of them will be upgraded. But the truly exciting part are the new devices that have never been used before in the LHC. And this is where my thesis comes in. My thesis revolves around a new device that is a central part for the LHC upgrade. It will allow for the collisions to happen in the most efficient way. Let me tell you how. In a particle accelerator, we don't collide particles one by one, because this would be highly inefficient. Instead, we collide groups of particles that we call bunches. When two of these bunches cross, some of the particles inside do collide against each other, but most of them don't, and continue their way through the accelerator. But how do these bunches cross, really? Well, probably not as you are imagining, because I told you a little lie. Bunches don't cross head-on in a circular collider such as the LHC. They collide more like this, with an angle. But if the bunches were to collide head-on, just as you are imagining, we would achieve the maximum amount of collisions possible. And that's exactly what we are aiming for the high luminosity LHC, with the help of the new, very crafty devices that I'm working on. These devices rotate the bunch just before the collision so that we have a crossing that is head-on. However, these devices can be dangerous in a case of a failure and could damage the machine. My job is to make computer simulations of these devices, study in which ways they can fail so that we can prevent these failures. In the meantime, while working for my PhD thesis, I'll try to imagine myself as Jodie Foster in the movie Contact, working for a really great machine, waiting for signals of other dimensions. Thank you.